gonna shade.
Shader's gonna shade.
Yeah.
Gonna shade. Shader's gonna shade, yeah.
Gonna shade.
Shader's gonna shade.
Gonna shade.
Gonna shade. Shader's gonna shade, yeah.
Hey everybody, welcome to a new episode of creating shaders in Max using the GL3 package, and specifically we are creating lightning shaders because this is basically our building block from which then we can construct more complex shaders. But when our objects are at least lightened up, then we have at least a realistic material to start on, and we can build up from that. Okay, so last time, this is where we arrived. We created a shader that creates an illumination using the Phong model, and using a point light we get basically a Phong lightning illumination on the objects. And this is based on distance, so the farther the light will be, the smaller the amount of light will be on the object. And this, of course, we can change by setting, for example, a multiplier for the dimmer. So if we say like dimmer multiplied by 2.0, this is basically going to make the light go stronger. So let's see if we can see the effect applied in real time. So if we say 1, it's going to be a bit darker. If we say 2, it's going to be slightly brighter. So we could actually include this into as a parameter that we can send to the shader. Maybe let's do it. So let's create our first parameter, which will be maneuvered using messages. So we can say param name equal light intensity. So let's call it U, light intensity, because this is going to be a uniform. And default, not type, let's write here type equal float. It's going to be just a single float. Default, let's set it to 1.0. Okay, let's bind this parameter to the vertex program. So bind param U light intensity program equal VP. Okay, that's it. So I remember you that I'm using Visual Studio Code as a text editor, which is pretty nice because compared to the built-in Max editor, it allows us to have word completion and suggestions and closing parentheses automatically on this kind of stuff. So it's pretty neat to use an external text editor in this case. So okay, so we bind the uniform to the program, to the vertex program. Let's now declare it inside the program. We can declare it probably. Let's declare it here. So uniform float, and let's call this. We call this U light intensity. Perfect. And then let's copy it and paste it instead of this number here. Okay. In order to avoid this line, we could just actually do something like this. We could put all of these into parentheses and then multiply that. Whoops. Then multiply that by U light intensity. Okay, so now if we go in our patch, and this is by the way our shader, let's actually give it a different border color so we can easily identify it. And let's create a message with written param U light intensity $1. And in this way we can modify the intensity of our point light. So let's see, yeah, exactly. We can make it very bright. We can make it not so bright. So it's pretty neat. We could actually, let me think, maybe we should clump it between 0 and 1 or something like that. So let's do like this, dimmer equal clump dimmer between 0.0 and 1.0. Let's see if this gives us better result, because then the light is not going to be crazy intense. Exactly, it's always going to be kind of, yeah, I think that's the way to do it. The maximum is anyway going to be always 1, so yeah, that's what we want, because otherwise if we don't do that, then the light will just go in unrealistic way too bright. Okay, so we clump it, which means the minimum is going to be always 0.0 and the maximum is always going to be 1.0, so yeah, we get definitely a better result. Okay, cool. Let's now maybe add another object here. Let's add the duck, which I like very much. So we will create a GGL mesh object, and then we will send the vertices from the duck and the texture from the duck to this object. So this is the context is called GL3 shad. And then we want to say draw mod triangles, because this is the draw mod you have to use when creating objects using a GGL model. So when sending matrices from a GGL model to a GGL mesh. And then we want to say auto material 0, which is the same thing we did, I believe, yeah, for the other objects, because in this case we can choose the shininess ourselves and it's not set automatically. Then let's say we can say matte diffuse, we can give it a nice white color, and matte specular as well, white. 0. Okay, then let's see what else. Yeah, that's pretty much it. Okay, so let's create a GGL model, GL3 shad. File is going to be duck.die. This is the duck file. Matrix output 1, automatic 0, because we just want it to be output once. So let's see. Let's create a load bank, so this will be output as startup when the patch starts up. It's connected to the first input, and here we have our duck, which is below. Maybe we want to normalize the object, so let's write normalize 1. Nah, doesn't change much. Okay. The duck is behind our sphere, so let's actually move the sphere to the left. So let's say position -2, 0, 0. Let's see where it goes. Okay, that's pretty good. Let's maybe scale the duck by 2, so it's double as big. And let's load bang again. Okay, as you can see, is rotated in the kind of the wrong direction. So I want to rotate it that it faces us. So rotate x, y, z at 0. Let's say -90 on the y axis and 0. So let's bang again, and there we have it. Okay, cool. Now let's actually scale a bit these. Let's scale the duck a bit smaller. So let's say 1.5. Okay, nice. And maybe we can put the floor a bit lower. So position -1.5. Okay, let's say -1.7 then. Okay, this looks about right. Let's apply the shader to the duck. So let's give it the shader attribute. So shader Phong. We called it Phong shader. Okay, let's load bang again, and there we go. We got our duck. Pretty nice. As you can see, it doesn't have a texture yet because we didn't use any texturing yet. So this we are going to do inside the shader very soon. So before we do that, I would like to encapsulate all the Phong lighting function that we created here, so the Phong lighting algorithm, inside a function, so that we can just then call a function called Phong lighting or something like that when we want the Phong lighting, and a function, for example, called with a different name when we want a different lighting model. Okay, so this is going to be very practical when we will have multiple ways to light up an object, multiple algorithms. Okay, so let's do it. First of all, let's actually create a function. So let's write here a comment functions. So let's write a function that will transform all our position, normal, and texture coordinates into camera space. Okay, because remember, we are when we get the data in, it's mostly going to be in world space. We want to transpose it into camera space, right? So let's create, or also called eye space. So let's create a function that does exactly that. So let's create a function that will not return anything. So void. So let's call it get eye space, and then we can say out vec3 norm. So this will be the normal coordinates, out vec4 position, and out vec2 text coord. So these are going to be the texture coordinates. Now, why have I written out? So in GLSL, we can define argument to functions in 3 different ways. We can define them as out, which means we are going to write on this variable, and the result is going to be passed out to the variable to which we are writing. Okay, so it's basically a bit like passing by pointer in C. So basically, the variable we pass in, it's going to be overridden. I don't know if you read it like this, but then we have in, which means we are just going to read the variable and not modify it. And then we have in and out, which means we are going to read the variable and also modify it. Okay, so this was without modifying it, and blah blah blah. Okay, so in this case it means that we're going to write on these variables, and as we output them, they will be different as the variables that came in. Okay, so first of all, let's transform the normals. So let's write norm equal normalize. So basically you can just copy our operation that we made here. Normalize normal matrix per vertex normal. So I just cut this and I just put it here. Cool, and then let's go with the eye position. So we wrote it as position equal this thing here. So model view matrix per vec4 position per the vec4 vertex position, blah blah blah, and all wrapped inside a vec3. So actually this should be a vec3, sorry. Alright, then we got the text coord, which is going to simply be, oh sorry, I got a bit ahead of myself with the text coord, so for the moment let's just not include them. Okay, so there it is. Okay, so then when we go here, we just do like that. We simply declare these variables. So light position is always going to be equal to the position of the light, because this is already coming in eye coordinates. Okay, so then we do something like this. After we declare the eye normals, let's call this function. So get eye space, and then we say eye normal and eye position. And this means that we are going to get the normals and the position out from this function already in eye coordinates. So gets vectors in world space and outputs vectors in eye space. Okay, by transforming them for those matrices that we declared up here, and we get as basically as a state matrices from the application from Max. Cool. Now we just have to encapsulate the Phong model inside a function. So let's do it. Let's create a function that returns a vector, which will be the color basically of the light. And let's call it Phong model. And then let's say in vector position, because we are not going to modify it. And then we need also the normals, so in vec3 norm, which also means we're not going to modify the normals. And okay, so let's see what we need. We just need to put everything inside, everything we did inside this function, and yeah, then we have to replace a couple of things with our coming in variables. This should actually be a vec3. Why I always make this mistake? Okay, so let's actually call position, let's actually call I position. And normal, let's call it I normal, so we don't even have to do much. We don't even have to replace stuff, but let's see. And of course we need also the light position. So let's actually put also this vector inside the function, since we're anyway going to use it all inside the function. Actually no, you know what? Let's put it outside the function. Let's keep it outside the function. And let's create another argument for the function, which will be the light position. So let's do like this. In vec3. How is this called? In vec3 I light position. So let's just copy it, put it here. Okay, let's try to save and see what we get. Okay, we still got some errors, of course, because it has no return statement. In fact, we have to return something, since we said that we are going to return a vec4. We are basically going to return the color of the light, which is composed of the diffuser, specular, and the ambient. So let's do something like this. Ambient plus, because the ambient is always summed to the other lights, diffuse, plus the specular, but these two are multiplied by the dimmer, right? Okay, so we still get an error. Undefined variable diffuse. Oh yeah, of course, outside of here. So let's do like that. I say GL intensity, light intensity, this is equal to actually our function. So let's see if this would work. Let's actually cut this comment. Let's put it here. Ooh. We got some funky stuff. Okay, so let's say Phong model, and this takes in the position, normal, and I light position. So I position, I normal, and I light position. Let's see if it works. Oh yes, it works. Great. So we basically replaced. Let's make a little separation thing. Okay, so we basically replaced the wall algorithm that we had just laying here with the calling of a function. So then when we want to call multiple lighting models, we just have to call their functions. So pretty handy. So let's recap what we did in this video. First, we created a parameter called uLight intensity, then we bint it, and then we declared it as a uniform inside the vertex shader, the vertex program, okay? And then we used it inside the Phong model function as a multiplier for the dimmer. So this is going to multiply the intensity of the light and we can use it from outside the patch. From outside the shader, we can always set the light intensity. Then we did also, we took the, we created a couple of functions. So one is get I space, which basically takes in the normals and the position as out vec3 and transforms them from world space into I space, which is necessary for the lighting calculation. And then we created another function that basically calculates the Phong model. So it takes as input the I position, the I normal, and the I light position, but only as input. Is not going to overwrite them. So we just have to write in, which means takes this variable as input, but not write on it. Okay, and then we basically copied the wall algorithm for the Phong lighting that we made in the past tutorials, and we return as an output, so we say here up that we return a vector 4, we return a vector 4 composed of the ambient plus the diffuse plus specular light multiplied by the dimmer. So only the diffuse and the specular are multiplied by the dimmer, okay? The ambient is just summed to both of them. And then inside the main function of the vertex shader, we call the get eye space function to transform the eye normal and the eye position, to transform basically the position and the normal from world space into eye space. Then we declare the eye light position as the position of the light into eye space. As you can see, we didn't have to transform it, because the light position from max always comes already into eye space. And then we use those three variables as parameters to the function that will return the light color. Okay, that's it. Nothing much more than this, but I want to stop here with this tutorial because I want to keep them short. So yeah, that's it. If you got some questions, please let me know. And in the next tutorials we are going to see some cooler stuff. Okay, thank you for watching, and if you like this video, please subscribe to the channel. This really helps, and put a like to the video as well. This would also show me your appreciation, and if you really want to show me a lot of appreciation, subscribe to the Patreon channel, in which I share a lot of patches as well, which you can download only as a Patreon. Well, that was it. Thank you very much for following. See you in the next video, and ciao.
Shaders gonna shade, yeah.